In today's note, we're going to be doing a little bit of a review from grade 10. We're going to be looking at right angle trig, and we're going to be looking at finding side lengths. So again, this should be a review from grade 10, but we're going to go through the steps and focus on how to label the triangles and how to find the side lengths given rate. So, like I said, we're dealing with right angle trig, and this focuses on right angle triangles, which is a 90-degree angle in there. And there are three sides that you're going to need to be able to label properly when dealing with it. It's the hypotenuse, the opposite, and the adjacent. So hopefully this is you kind of remember these terms, but if not, again, that's fine. We're going to go through how to label them or find them correctly. One thing to note, labeling a triangle should be your first step when dealing with right angle trig. It's important to label the triangle correctly because it lets you know what ratio you have to use. So here is our right angle triangle. Usually you will see a square, which means a 90-degree angle. 90-degree angle means it's a right angle triangle. Now the first side that you can always label first is the hypotenuse. And the hypotenuse is always across from your right angle. Hypotenuse is always across from the right angle, and that right angle is not going to change, which is why it's one of the first sides you can always label. Cross. The other thing, the hypotenuse, you may remember from Pythagorean theorem, it is the longest side. However, I would stick to always looking for it across from the 90-degree angle, only because depending on how the triangle is drawn, the scale, how it's rotated, or how it's flipped, whatever the case may be, it may sometimes be difficult to figure out which side is the longest. But however, the 90-degree angle, that doesn't change. That's why I say always look across from the 90-degree angle first, and then you can determine, well, is it the longest side, which it should be anyways. But if you stick to focusing on across from 90 degrees, you should always be able to find it. The next thing we're going to do, because we need to find our opposite and adjacent, we need to use another piece of, and that would be an angle. So what I've drawn here, this little red symbol, this symbol is theta. And this just represents an angle. Theta just represents an angle, and I'm going to refer to it as a reference angle. And the reference angle is either given to us or it's unknown. That means it's either in the question or it is or we're being asked to solve for it. One thing to note, this reference angle can be in either location. So it could be down here. It could also be up here. It just depends on the question. I'm going to leave it at the top for the purposes of this example, but just know that the next two sides that we label could be flipped depending on where this reference angle. So across from my reference angle is what we call the opposite side. And it's the opposite because it's opposite of my angle. But I'll just put across from the reference angle. And that leaves us lastly with our other side, which is the adjacent. And if you think of the word adjacent, adjacent means to be beside. So adjacent side is beside the reference angle. And you know it's only going to be this side because the other side is the hypotenuse. So that's how you can determine or label your three sides. Hypotenuse is always going to be across from 90 degrees. Your adjacent is always going to be beside your reference angle, and your opposite is always going to be across from your reference angle. Keep in mind the adjacent and opposite. This example here, they may be flipped depending on where the reference is. It's not always going to be. However, the hypotenuse will always be across from 90 degrees. Once we've labeled our triangle, we can use that to help us determine which ratio we can use. And there are 3 of them. Sine, cos, and tan, you can see them down here. Sine theta is equal to opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. And remember that this symbol here just represents an angle. So it'd be the question. If you'd like, you can also use the acronym SOHCAHTOA. Again, you may remember this, but that's just sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And then tan is opposite over adjacent. So again, it's just an acronym to help you remember what your ratios are, but you can always refer back to your notes to find this. So we're going to look at an example of each ratio and look at how to solve them. So here we have our sine ratio, and here we have a triangle or a magic triangle. You may have seen something like this in science or electricity or physics. So you can use either method to help you solve for a missing side. I'm going to show you both using the formula and using the triangle. Either way, it's the same thing. Regardless of which method you use, though, you still have to label your sides. Even though I'm telling you it's the sine ratio, let's still label our sides to get into that habit. So across from 90 degrees is our hypotenuse. See our reference angle of 30 down here because it's given to us. So across from that is the opposite, and beside that is the. Once I've labeled it, I'm going to figure out what sides am I dealing with. I'm dealing with the hypotenuse because it's given to me, and I'm dealing with the opposite because it's labeled as x, which means I need to solve for it. So those are the 2 sides. I'm not dealing with the adjacent side because there's nothing there. No symbol, which means I have to solve. There's no given information. Even though I've labeled it, I'm not going to be using it. The only ratio that deals with O and H, or opposite and hypotenuse, is sine. So I am going to write that out first. Sine theta equals opposite over hypotenuse. And then I'm going to fill in whatever information is given to me. So sine theta, remember, is the angle, so 30 equals opposite, or x, over 16, or the hypotenuse. Once we've filled in our information, we need to solve the equation for x. And the nice little trick here is, without going through the steps of solving the equation, moving things around, or canceling things out, whenever you're missing the top piece of information, so in this case we see top part of my ratio or fraction is missing or unknown, I'm going to bring the bottom up to the other side and multiply. So that's what this note over here is. Missing piece is on the top, I bring up and multiply. So 16 times sine 30 equals x. We see that 16 is now up, and we're multiplying, and we should get a final answer of 8. That missing side length. So that's using the formula and solving it algebraically. If you choose to use the triangle, what you do is you cover up the piece that you're missing or you're trying to solve for. In this case, I'm trying to solve for O. I'm going to cover it up. You could cover it up with your thumb. You could, but I'm just going to highlight it here because I don't want to hide the O. But we cover it up, and what we're left with is S times 8. So what that means is it's the sine theta times 8. Or times the hypotenuse, and that will tell me what my opposite is. So you can see already that it's going to be the exact same operation that we get to when we're solving algebra. Sine of 30 times 15 will equal x, and 8 equals. So either way you choose to do it, you still get the same final answer. You're still going to that same operation. The next example, we're dealing with the cosine ratio. I'm going to start by labeling my triangle again. Across from 90 degrees is the hypotenuse. My reference angle of 50, so across from that is the opposite, and beside that is the... What two sides am I dealing with? Well, I'm dealing with the hypotenuse, and I'm looking for the adjacent. Right? The hypotenuse is given to me, and I'm looking for the adjacent. The only ratio that deals with a and h is cosine. I'm going to write out that formula. And then I'm going to go back and fill in my given information. Cosine of 50 is equal to known over 40. Again, this is very similar to that last question where I have the missing piece on the top. So I have to bring that up and multiply. So 40 times cosine 50 is x. When I do this on my calculator, I should get 25.7 equal to x. I can do the same thing with the triangle, or the magic triangle. Again, I'm looking for the adjacent, so I'm going to cover that up. That leaves me with c times h, or cosine theta times the hypotenuse. Give me the adjacent. I go through and fill this information in. Cosine 50, 40, adjacent, which gives me the same value. So again, it's up to you, whichever one you choose. Tangent ratio. So again, even though we know it's tan, let's get into the habit of labeling that triangle. So across from the 90 degrees is your hypotenuse. You have your reference angle of 33, so across from that is your opposite, and beside that is your adjacent. Once we've labeled it, we want to know figure out what sides we're dealing with. Dealing with the opposite and the adjacent because they're given to me, or one is given to me and the other one I'm trying to solve for. The only ratio that deals with O and A, when you go back to all three, is the tan ratio. So I'm going to start by writing that out. Tan theta is opposite over adjacent. Fill in my missing information. Oops, sorry. Theta is our angle, so it's 33, not 16. Opposite is 16. The adjacent is x. Now this question, a little bit different because now the missing piece is on the bottom. And when the missing piece is on the bottom, as you can see by the note over here, we have to switch and divide. What I mean by that is I have to switch the tan 33 with the x. Now, if you remember from before, or even entering the calculator, tan 33 just gives you a single. So we're going to treat the whole thing as 1. And I'm going to switch the two. That means x is going to be up top, and then the tan 33 is going below. That's what I mean by switch. Then I have to divide 16 by tan. So when I do 16 divided by tan 33, I get a final answer. Side length. That's what we mean by switching and dividing. If I want to use the magic triangle, I can do the same thing. Oops. I'm going to cover up the missing piece, or what I'm trying to solve for, which in this case is now the A, which is on the bottom, which means it's O over T, so it's opposite divided by n. And if we look at our formula algebraically, that's the same thing that we ended up doing. So the adjacent equal to the opposite divided by tan theta. Adjacent was x, opposite was 16 divided by tan 3. And we can see again it's the same operation. We should get the same final answer. So whether you choose to use the magic triangle or the ratios and solve algebraically using two notes of switching and dividing or bringing up and multiplying, it should get you this. Now, the one thing you want to be careful of, even though in these examples, when we did the sine and cosine ratio, it was always the same, the top was missing. It could also have the same type of question where the bottom is missing. Then you have to switch and divide. Even though in the examples you're only seeing one way, keep in mind that it could also be done the other way. The nice thing about this trig though is that there's only two operations, and either bringing up and multiplying like we see in the first two, or you're switching and dividing like you see in the bottom one. The only thing that will change other than those two operations is what ratio. So whether you have sine, cos, or tan, once you figure that out, you're either doing one of two things, bringing up and multiplying, or switching and dividing. That's the nice thing about trig. Once you label it and figure out what ratio, not too many options of what you can do. Again, hopefully this was a review, but again, take the time to go back. Remember to label your triangles first